Well, good morning, geometry. It's good to see you. I mean, in a sense, this is weird. This is different. But for us, this is something we've done from time to time, right? So I know we're going to be doing this extended a little bit more than normal, but hopefully these videos are helpful. Again, one of my concerns all through this process has been us communicating. So please don't hesitate to email if you have questions. And then even as you do, I want to remind you that normally on Tuesdays and Thursdays, we'll kind of get together in some way, either live stream or Zoom, so that we can kind of work together in a little bit more precise way, me getting some feedback from you and answering your questions. All right. So we are on lesson 9.5. If you don't have your notes out, please get them out right now. So I'm just going to pause really quick while you get your notes and ready to go. All right, even as you've done that, I just want to encourage you, if you don't have like a designated workspace that you're going to be doing your schoolwork in, can I just encourage you to do that? It's really helpful when you have kind of a consistent set place. And just again, an encouragement that it's a quiet place. You're not going to be distracted by things. Just so you guys know, right? I'm at work, and part of that is because I know that if I were at home, not that I won't ever be at home, I know there are distractions, right? And I want to go play with my kids. I want to go do things like that. So I'm trying to come here, do these videos, focus on you guys, right? So that it doesn't take me all day long, and then I can go and work. So. Lesson 9.5, we're talking about tangents. And when we're dealing with tangents, I want to first start off with and tell you that it is connected. There's a connection with sine, cosine, tangent. However, it's not like the exact same thing, okay? Think more, maybe because it's helpful, just in terms of the picture. Think in terms of a rabbit trail. Right, like if you've heard somebody say, we're gonna, like, I just went off on a tangent in like a kind of more of a speaking context, is if you're on a train of thought and you're like, oh, that leads me to this, and then you go off. That's what you're always hoping I do in class, right? So for tangents, we're gonna use the Pythagorean theorem a little bit, but deal with specifically the properties of tangents and circumscribed polygons, okay? A polygon that's drawn around a circle. So we'll show you that in a little bit. Some vocabulary we're going to cover in just a moment is these things. So what is a tangent, okay? A tangent is, let me get my eraser there, is when it's a line that touches a circle at exactly one point. Okay, you can see here this picture, this is like what we would call the point of tangency. Okay, and just to throw it out there, I was just talking about this. So imagine I was teaching class here, and when I got to this point, all of a sudden I go off this line, right? I go off on a tangent. Okay, it only meets the circle at one spot. Right, and that's normally what a tangent does. If I was teaching the lesson and all of a sudden I went on a tangent, it's because something connected me to the lesson, and then I'm off, and I might never make it back, right? So this is the point of tangency, and it touches a circle at one spot. Now, one of the practical difficulties of showing this in a textbook is it doesn't always look like it touches it at exactly one spot, right? We're talking about like to the pixel, it might show it touching at more than one. And what I mean more than one is you can even see here, let's try to zoom in a little bit on this spot. Okay, you can see it kind of looks like maybe it's touching it right here as well. So it's hard for us. So we don't want something that looks like this. Obviously this is touching at more than one point, right? You've got a dot here and you've got a dot here. But they're trying to draw this. So anything that looks like a tangent that we would understand, like the book is trying to show us a tangent, we're going to say it is a tangent line. Okay? So some unique things about tangents, you've got some of these things, is that a circle can have different kinds of tangents. They could have no common tangents. Okay? No common tangents would look like this. There's not a line I could show that is tangent to both of these. So, like, notice if I draw a tangent to this one, it's going to touch the bigger circle 1, 2 times. If I tried to draw something to this tangent to this one, it's never going to touch this one. So there are some times where they have no tangents, okay, no common tangents, and then there's other ones that have like multiple, okay. So like these guys here, I could have something that looks like this, or something that looks like this. Right, those would be common tangents. This one, kind of interesting. This one actually has a lot. If you look at this guy, we can go with these. Again, notice I missed a little bit. I'm going to try to connect it with a dot. Okay, but you also have one kind of going right through the middle here. That one's going to touch those circles. So you can have 2, you can have 3, you can have 0, you could have 1 sometimes. Right, just depending on the circles and how they're laid out. Okay, one picture where they would have 1 is if they're like this. Right, they only have 1 tangent line. If they're all kind of meeting at one spot. So different kinds of options for us in terms of what a tangent can look like. Okay, I just drew this example for us because I think this is helpful. Maybe something a little practical for us. As you draw this out, it should look something like this. No, those are not perfectly straight. Okay. That's how the sunlight will come to the earth. And there is then casted by the moon a shadow within that range. Okay? So if you're in this range right here, you're seeing a total eclipse. And if you're in the little areas right here or right here, you're seeing a partial eclipse. So you can just see how the tangent lines from the sun to earth basically kind of create this effect that we would have. All right, so just kind of interesting, some dynamics there, some real life application where tangents would come into play. Actually, shadows often take into consideration tangent lines. Okay? Some specifically mathematical features that we're going to deal with. Number 1 is theorem 9.10, and what that says is that in a plane, if a line is tangent to a circle, it is always perpendicular to the radius. And notice this is an if and only if statement, which means if you have a radius that's perpendicular to a line that appears to be tangent, okay, at one point, then it is a tangent line. All right, and all of that means we should be looking for right triangles and using the Pythagorean theorem. That's going to help us to solve these. So you have an example right here, all right, and it says, hey, determine whether this is tangent to the circle. Well, in order to determine that, I want to know, is 20 squared plus 21 squared equal to 29 squared? And this is a question I'm asking, is this a right triangle? Okay, I just got to figure that out. Well, you got 400 plus 21 squared. Just double check this here. This is 441. So you got 841. And 29 squared is 841. So that would mean that, yes, this is tangent. Okay, and our justification is our work, but I would want to add, right, because this is a 90-degree angle, right? Because the radius drawn to that line it's a segment, in this case, is a 90-degree angle. Okay. Notice on this one, a little different, and they can do this in various ways, but it asks us to find x here. This is a radius, and this is a radius. Okay? They could do this in lots of different ways. In this case, they made both of those the unknown. Well, Pythagorean theorem says x squared plus 24 squared equals, and I want to be careful, this entire thing is x plus 16 squared. Okay? Depending on where they put different numbers, you might have to factor on a problem like this. This one you actually don't, but you do have to FOIL over here. Okay? So you have x squared plus 24 squared 24 squared, 576 equals, and then over here, if I were to FOIL, right, because x plus 16 squared is x plus 16 times x plus 16. And so we're going to do our kind of double distribution, right? So it's x squared plus, that's x times x times 16 is 16x, plus 16x, and then the last one's plus 256. So what happens is our x squareds, when you subtract from both sides, go away. And we have 32x, let's get rid of our 256, minus 256 is 320. And notice if I divide both sides by 32, x equals 10. And so the radius in this case is 10. Now I just want to throw this out there for you, right? One of my thoughts right away when I got to this problem was maybe, just maybe, this is a 3, 4, 5. Okay? It's not, okay, this is 36. You got 10, the 24, 36. I'm like, I at least thought through it in my head to see if there was a number that made it work, right? 24 is divisible by 3 and by 4. So out of the two, because this is the smaller one, at least by the way the picture is drawn, I am kind of thinking through that first. This would have been the 4. So it would be like 24 divided by 4 is 6. So 6 times 5, right, is, I'm asking, does that work? 6 times 5 would have been 30. I'm like, 30 minus 16 would be 14. And I've got 14. That means this is 14. That doesn't fit a 3, 4, 5. Okay? Because this would have to be 18. Right? If that didn't make sense, just to draw it out a little bit specifically, if I had 3, 4, 5, sorry, okay, and this turned into 24, it was a multiplier of 6. So this would have had to have been 18 and 30. So I was seeing, okay, I didn't write any of this out. I did this in my head really quick as I started this problem because I'm always thinking about these things, right? Our Pythagorean triples become very helpful for us and seeing if we can come up with a little bit of a shortcut. All right? All right, theorem 911, okay? If two segments from the same exterior point, so you've got an exterior point over here, are both tangent to the same circle, then they have to be congruent, right? These have to be equal lengths. Right? I kind of think of this as a little bird beak, okay? This is a little guy, okay? He's got some little feathers, all right? And the top of his beak and the bottom of his beak are equal, okay? Now again, they could do things like this. They could divide it in half, and they could make a radius here and a radius here. Get a little more of the bird guy going on there, okay? With those 90-degree angles. Okay, so you have some options in terms of what they might do, but ultimately we know that these two things, these two tangent lines, are equal to one another. Okay, so in this case, it's as simple as 5x plus 4 equals 8x minus 17. That's 3x, okay, equals 21. So subtract 5x from both sides, add 17 to both sides, you get 3x equals 21. X equals 7. Okay. Now please be careful. I mean right up here, find x, right? But if they wanted us to find mn, make sure you're reading the instructions carefully and solving accordingly. Okay. All right. Last one. This is a picture of a shape, a triangle in this case, that is circumscribed about a circle. Meaning, to circumscribe means to draw around. Circum, around, scribe, draw, right? So, to draw a triangle around a circle, right? I'm thinking about maybe some of the questions might be in words, right? Instead of giving you a picture. So this is what something like this would look like. And so what I know is, what they're telling you is that from S to M, that is 10, which means that S to N is 10. Notice this is our little bird, right kind of here. All right. But you have a bunch of these. Oh, that was bad feet. All right. Not that it was good in the first place, but okay. So you have that one. You have the same thing. If this side is 2, this side is 2. And then if this entire thing, notice they're kind of doing it a little different. If this entire thing is 8 and the top is 2, this is 6 and this is 6. So for the perimeter, you have 16 here for this entire side. You have 12 here for this entire side, and you have 8 here. So all we're going to do, add those all together, and we're going to get 36 for our answer. All right? So if you've made it to the end of the video, awesome, great. Notice it's not super long, but I know that you're going to be filling in your notes. You should be, okay? And now I'm going to give you what, I'm going to say like, right, homework, but you've got an hour slot here for your class. So I'm going to do this in the very first one I just want to mention. So it's kind of what we'll do is the lessons aren't going to be taking up, the entire time unless you're sitting there pausing, taking time to work through things. But I'm trying to walk through a little bit more with you. And so your job is primarily now to go practice that stuff, right? I don't want to make us on these videos for hours and hours because I know that you're doing this for other classes. On top of that, I want to make sure we're thinking through. So like tomorrow, that would be Friday. Tomorrow, we're going to do something called Zoom, okay? And so Zoom is basically an online classroom of some sense. So that'll be a time for us to kind of get some feedback. We'll go over homework together. We'll answer those questions. And when I have you there, I'll talk to you a little bit more about what we'll be doing going forward. All right? Thanks for watching, and we will see you tomorrow. And I look forward to getting to see you guys a little bit more face-to-face. All right?